Hello. Hi there, everyone. Hi and welcome. And oh, I just realized I haven't set up the camera. Give me a second. Give me a second. Just need to quickly. Right enough. Yep, that should be proper. Hello. How are you all doing? Hi there, hi the Stamp, hi the Westin. Hi and welcome. And today we will just literally just try to play a sound. That's it. That's the goal for the entire live stream. Just to play a sound. Yep. All we're gonna do today is just let me just unpack it. No, that's not it. There we go. Raspberry Pi Zero. I'm gonna take out the Raspberry Pi Zero and yep. I'm gonna take it, connect it to the audio amplifier. Audio amplifier is already connected to this right here. In order for us to power it up, all we need to do is just plug in this cable in here and make it. You already played more than one sound via my headphones, so no. We're gonna have to play it proper. We're gonna have to play a sound proper. I also forgot about one more component, so I will be right back again. How are you all doing, by the way, on this fine day? How is it going for you all? I really hope that I have my cable around here somewhere, because I'm gonna need a USB cable. Oh, I do. How convenient. So, and I hope it can power it. So, we take this. This is our Raspberry Pi Zero, which will obviously we'd like to play the sound on. And then we plug it into the power, which is the top one. Like this. It's plugged in. The LED is not flashing, which is a pretty bad sign. Uh-oh. Whoa! Is the USB cable messed up? I mean, in that case, I suppose I do have a backup USB cable right here. This should work just fine. Otherwise, this is a bit short. It's always something, isn't it? It's absolutely always something. No, I can't just plug it into my computer. I ain't gonna do nothing. It's always something. It is absolutely always something. I can look for a... What can I look for? I think I have an adapter from USB-C to the old USB. That's what she said. It beat me to it, actually. I don't know why I didn't say it. If I had a nickel, am I right? If I had a nickel. I'm pretty certain somewhere in my 30,000 different containers I have a USB-C to typical USB converter, which we could use along with this cable, which is USB-C cable, in order to power the Zero. If only I could find it. All I need to do is just find it. Once I find it, then we are golden. And how hard could it be to find? It's just a tiny little piece of electronics, just somewhere in my electronics drawer, right next to all the other things that I have. Just simple, unsuspecting. Fucking hell, there are so many things and nothing I actually need. Did I really not put my adapter in any... I must have put my adapter in some different place. I refuse to believe I would chuck in my adapter with all of the electronics, would I? USB type A. Yeah, that's the typical. Not the one I need though. Damn it. Why isn't this cable working? Why can't you just power up? You used to work. This is ridiculous. Preposterous. Maybe I just need a higher wattage. Wattage that cable won't be. Well, I know that this cable for a fact can supply that kind of wattage because this cable can power up Raspberry Pi 5, which is more than enough. It could be on my boxes as well. Fucking hell. Hold on, I will be right back. I need to go find a USB type A cable I can use because for some reason the Zero just uses USB type A. I don't know why. Okay. Golden rule of the universe right now. This is the golden rule of the universe. In a pinch, when you need a cable, a USB cable, or more specifically, when you need a very specific kind of USB cable, you will be able to find not one, okay, not two, not three, not four, not five, but there is also a 6 and a 7th in my drawer that I wasn't able to pull out. USB cables with all of them being the wrong type. Every single one of them is the wrong type. It's fine. No, it's good. Whatever. I'm gonna keep them right here in my workshop in case I need them in the future, because I might. But it's good to know that I have so many USB cables, all of the wrong type. I can just pull out this USB cable of my computer and then just see if it can move enough juice. My hopes aren't high. No, I definitely have the... Anyone remember where I put my USB-C to Type A adapter? It's not gonna lie, I could really use one right now. Anyway, everyone, how are you all doing? Make it. Are you aware that USB-C needs PD power? Anything besides power, it needs to be negotiated, so you can't exactly just push 240 watts. I have no idea what you are even talking about there, although. If I wasn't enough, this is ridiculous. How am I already falling short on this part of the live stream? Just setting it up. It's in the USB-C to USB-A drawer, I swear. Why can't things just use USB-C? We don't live in the 12th century anymore. Just use the USB-C. USB-C is just the best system. Why do all of the other standards even exist? They should have been wiped out with the meteor that killed the dinosaurs. I think I found it. There we go. There, I found the adapter. Fucking hell. Oh. Right. Go on in. There we go. Found the adapter. Yeah, I have no idea what Olo was talking about, but I'm used to people being wrong about what I can or cannot do. So I won't even go into it. The point is, if I now do actually what we should probably figure out is VS Code external file system with SSH. I think that was a thing, if I'm not mistaken. Remote development using SSH. Yeah, that would be nice. I have that, yeah. Remote SSH extension. I don't know if I can set it up right here because I kind of used that before in the past. Okay, I will go to CDQ workshop long-term mask code. I was talking about using USB-C for powering something, although I am literally right now using a USB-C for powering something. Okay? Suck on that. Okay, so what we'd like right now is to use the VS Code for SSH. SSH. Yeah, I already have it enabled. Okay, in the meantime, how are you all doing on this fine day, huh? Because no one really answered much. Hi the chemistry Nick, I'm sorry, degree 3 tries. I'm a bit shaken by just how few USB-A cables I have. It's honestly a problem. I don't like the standard USB-A. USB-C is incredible. Why is USB-A still a thing? It bothers me on a spiritual level. Why do we need so many USB types? Nick's good. My day went great. Woke up from a 14-hour nap at 7 AM. What happened? 14 hours? That's a lot. What happened? I've been amazing. I'm doing organic chemistry, losing my mind over the mechanisms. Ooh, what are you studying organic chemistry for? That's curious. Alright. First things first. Let me delete this folder. It's not necessary. Delete permanently, yeah. Surgery, I would like to keep. Surgery will be useful. There's a history of USB, you know why there's so many USB port types before C. I know why there were so many USB port types before C, because I'm not 7, alright? I've lived through the time of... I've lived through USB ports being developed. I have lived through that time. But as I mentioned, we don't live in the 12th century anymore, okay? This is no longer a prehistoric society. We can use USB-C now. USB-C is amazing as far as I don't have the same data throughput peak USB-A has. Let's actually see. USB-C versus USB-A data throughput. Power, speed, and performance. Let's have a peek. You're not gonna give me a graph, you're gonna give me solid text. This is a technical point. I'm looking for data. I'm not looking for words, I'm looking for data, graphs, numbers. That's what I'm here for. I like this supports my point, but I don't trust this. Give me something, give me graphs. This feels like a measurable thing. Which is better? I don't care, I care about data. Am I wrong? Can you not measure? Because as far as I'm aware, data throughput. What are you trying to do, make it? Well, I mean, right now we're going on a tangent to see which kind of cable can move more data, USB-A or USB-C. Hi, the Adrian, hi. Okay. For some reason, code still hasn't deleted the thing. Let's open another program. Oh, I know you're still in progress because you haven't done the one thing I asked you to. Okay. Windows, I swear, I'm going to demonstrate you. That's what I'm going. I am going to just straight up defenestrate you. Open again, yes. This off. Firefox has opened another program. What program are you opening? RM, RF, X, lib. Ow! Come on. Permission denied. Why? Permission denied. What kind of permission do you need me to have? I am the owner of this machine. What kind of permission do you want me to have in order to delete it? Because I can tell you I have that permission. Open in Java. You are open in Java, huh? Well, I'm not using Java, right? Worst case scenario, I'm gonna turn off something I shouldn't have, but that just happens. There we go. I don't respect Java anyway. Beautiful. Fixed it. Okay, we've got this now. Splendid. So first tangent finished. Now onto the next tangent, which is I need to remote SSH into my Raspberry Pi. So first let's see which one I'm SSHing into. SSH make it at 192.168.108. Well, I'll be damned. I guessed correctly on the first try. So there's 8. Okay. Which means that What's status bar? Alright. Once again, I need to turn it off, just in case it pops up something that... Yes. New host. Make it at 2168. Okay. Seems like speeds are largely the same, but USB-C also has access to USB 3.2 and 4.0 standards, right way faster, so I was trying shit. USB-C equally fast and not faster. Exactly! USB-C is just objectively better on all fronts. I don't know why A is still a thing. You can use USB-C for power and data. Like, video is sent over USB-C. Power for microcomputers is sent, or boards of any size is sent over USB-C. It is wild. You can do anything. Make it, I sent you the charts on Discord. Where did you send them? DMs. My DMs are closed because I get too many bots. Okay, there we have it. Can I have file? Can I open a file from the repository? Well, wait, hold on, because I am connected to a remote. Oh, wait, what? Am I gonna open it with? Oh, whatever. ls make let's call it. That's a good question, actually, because technically we should set it up as a kernel module, but practically we won't. Make the sound tests. Sound test, alright. Do I just code it now? Open. Oh! Oh, I need to add password again, just in case. Yes, I chose the authors, I just made it. Oh, splendid. Oh, how lovely. This is really convenient, actually. You want to change child to child checkups? Well, yeah, that's normally where everyone sends it. Now, the reason why... This is not the right thing. The reason why we wanted to open it up was because... Well, I need to find the... There we have it. Is this? This is port audio, which, well, as it says in about, cross-platform open source C language library for real-time audio input and output. But more importantly, the reason why I want to use it is because it can open audio files, as far as I'm aware. So, documentation, lovely. Let's get to it. This will be fun-ish. Sent, you say. Let me see. Oh, just link Wikipedia. You could have just told me to go on the Wikipedia article. Right. Lexi deprecated. There we go. So Type C up to 60 gigabits per second. Okay, so 160 total bidirectionally, right? It's actually also really cool that I can go 120 and 40. That's really neat. That's a really neat thing. Whilst B, that's 10 gigabits, and oh, come on, that's ridiculous. Yeah, just Type C is just objectively better. It is just objectively better. I don't understand why. Why do we use A or anything else? Ridiculous. But yeah, port audio. Let's get through it. A big sip of coffee. And now it is time. To get through it all. Okay. Documentation. I imagine V19. How to compile and use. Yes. Compiling. Building port audio for Linux. I imagine this would be a bit of a start. However, writing callback function. Oh. Oh, by the way, do you genuinely need to build it? Not like a package or something, because it's a very, like, it's a massive project, isn't it? Yeah, like 56 contributors. Version 19. 2,000 stars. Okay. The user sound API is very old and not well supported. It's recommended to use also sound API. That is simple. That's something I can do. Sudo apt install lib a sound dev. Simple. What language do you recommend to learn? For what? For programming. You need to specify what kind of programming you'd like to do, if that's what you're asking. Because it depends. Mostly Python and C, I would say. Python for convenience and C for really fast programs. Apple's Lightning cable is still faster and better because it's called Lightning, not like USB. C, because like absolute C fanboy predicted. That was a very tough prediction to make, Adrian. I have only spent years coding in C and Python. By the way, have you seen Brainfuck? I've heard of it. I've heard of it. Okay, splendid. Make tools. Oh, I need to get make. Oh. I mean, that's reasonable. The only problem is I don't have Jack. Hold on. Linux Libase sound dev. Just out of curiosity. Linux sound. I'm sorry, what now? Oh! Linux. Oh, Linux. Oh, Linux indeed. I'm sorry. Interest a bit peaked. ArchWiki, of course. Okay, let's... right. Not quite. What I'm looking for, documentation, yes. Applications would be nice as well. Always let mix MPC of it, probably also open sound system. That's a driver. That should work, right? That has to work. In my case, yes. Okay. Out of curiosity. Yeah, because the problem is basically that I don't that this is pretty advanced way to code stuff, isn't it? And so the difficulty is that I'll not only need to make the program, I also have to figure out how to, in what way should I make it? Because there is first the most idiotic way. Well, not the most idiotic. I shouldn't say that's mean. The simplest way, which is I could just get the library to do it for me. I could just find the library. Someone probably made one already for, even specifically for Raspberry Pi Zero, I imagine, for playing sounds. That's the simplest one. However, in my case, I want to go a bit more in depth, which means I would ideally like, well, what I would like is a C library for reading sound files. That's what I would like. Tiny valve, that sounds nice. Maximum portability, you've piqued my interest. Okay, so you take number of channels, sample rate, block size, go in, you open, oh, that's you open for writing. And then you add in the samples. And then for reading, you do the same thing, so you read TW. Okay. Samples are always provided in a float 32 format, regardless of the file sample format. So you take the float samples, you make an array for number of channels times the block size, right? Buffer request pointers channel, yes. Okay, so far I'm with you. No, I'm sorry, what now? Wait, the samples. Oh, this throws me for a... Oh yeah, because it's pointed to an array of floats. Or just do double pointer. Or maybe it's or maybe it's me who is an idiot in this case, because a double pointer might be actually less readable. Right, so in this case, this is... we can imagine it as... the float samples array being a huge block with just a bunch of different floating point numbers. Then sample pointers will be just 2 of them. That's our structure so far. Then we read into sample pointers. Okay, so the structure matters in this case. And that loops 100 times. Why does it loop 100 times? Because... can only read, write, revise with sample format float 32 or int 16. Oh, will that be a problem for me? That's a good question. Let's explore our options first before we decide. That's useful. That seems pretty lovely. I am interested in source code. Simply just take a bit of a peek at the documentation. There it is. Okay, that doesn't really work. Okay, the definition of insanity. Okay, doing it without documentation, that might prove to be a bit challenging, so... Oh, yes, absolutely. The web design of these websites inspires confidence in me. Give me sample sounds, MS Windows Java and upwards, okay. Right, features. Read and write a large number of file formats. Easy to use API, okay. Documentation, may I? I would be really interested in the documentation. May I please? You know what is good when it just takes vocation to H1 and a hyperlink. Yeah, that's how we know this is real shit. This isn't some kind of Meta presents Facebook audio library, which is just like a call to a chat GPT to just generate the sound you're looking for. No, this is proper programming. This is proper, one half of it written in assembly, the other half just manually generated binaries that some poor soul had to just add in there. Because back when it was getting developed, most programming languages didn't even exist. Programming interface, I imagine, will be it. Okay. I'm just curious, by the way, because I do have dark reader on. Oh, it should be pitch black normally. Oh, that is much better. That's so much better. Okay. It used to be called samples. It's frames. Okay, so we have the SF info, which is being returned. Makes sense. Double check. Quick question: what is the mode? Oh, this is lovely. I love it. I love it so far, but I don't know if I'll be able to use it. You know what I should do first? It just hit me. The most important part of developing in general is reducing the points of failure. And that means you need to start with the things you're most confident about and then move on to the things you're less confident about. Because that way you first lock in the things that you know work, you lock them in, and then later on when you reach a problem, you can only focus on the thing that you were uncertain about. You know, the things that might not work. So how about we first start by just playing a sound. Not proper sound, or rather not playing a sound, only making noise. That's it. How about we start by making noise? That's because making noise should be really easy. So, and once we do that, then we'll at least have that locked into place, and we will know that any problems that may arise later on will be the result of me not being able to use the libraries properly, and not due to any hardware shenanigans. Making noise better than making music. Well, ideally, what I would like to do is I would like to play the Make It theme over my setup. That would be quite, I do believe, sick. Beautiful. So now what we're going to do is we're going to solder this into... Should I do left and right, or should I do left and ground? Yeah, let's do a mono speaker for now. For now, so right here, you can see it, that's our speaker. And then we're going to... I love the complex logical equation there. Oops, this cable is underneath. There we go. Yeah, just... There we go, make it. Just throw around a scalding hot soldering iron. That ought to be fine. Oh, how did I solder them so well? That is unnecessarily well soldered. Not even unnecessarily well soldered, that is actually upsettingly well soldered. Piss off. There we go, one. Now a second. Two. Beautiful. So this, I unsoldered the wrong fucking thing. Shit. Plus, is this the plus? No, this is the minus, okay. Shit, take it back. Go back in, you're doing just fine. It just hit me that past make it actually thought of that, because apparently the only thing soldered here, that was the speaker, which is not what we had to desolder. Whoops! Right, stay there. You're doing great work, I take it back. Keep doing what you're doing. You're doing so well. Keep at it. Alright. So apparently we don't need to desolder anything, because past make it thought of that already. And all we need to do is just unplug the... Let me make sure you see it better. All we need to do is unplug it from the Raspberry. Blue is the ground. And then plug it into the appropriate pins. Which pins will we use? Well, there is the website. I do believe it's called Pinout XYZ. Ah, lovely. We can do... What can we do? We can do the inner, and then... that's the I to C. Fucking hell. 3, 4, okay. 1 to 3. At least it should be. Fingers crossed that it is ground. And then afterwards, 23 and 24. Those are the pins we'll use. Come on, get in. Get in. Get in! You're not going in. Why are you not going in? Does not feel like you're going in. Yeah, you're absolutely not going in. Go in. There, that's my boy. 1, 2, 3, 1, 2, 3, 3, 1, 3. That should be correct. Which means that now, what we can do is we can see. So the right one, that is the yellow, which means GPIO 23. If we plug the entire circuit back into power, which we can do by just picking up this cable right here. I said we can do by just hooking up this cable right here. I said, go. Then let's try it. Just program now whatever noise.c. Here's what, oh, how am I gonna run it actually? How am I gonna run it? What we need is we need wiring pi pulse width modulation. That's what we need. Ideally. Okay, so includes what's happening with me? Why can't I type? Why can't I type? There, now I should be able to type. This wiring pi, or was it wiring pi with a capital H? Who cares? Well, I care, because if I do it incorrectly, I'm not gonna be able to run it. Wiring pi, lowercase w, that is correct. Then what we're looking for is we're looking for example of how to use PWM. That should be examples, and then in here there should be PWMC. Lovely. It's very short, which makes sense. It should be. All right. Now that's a banger for loop. Banger for loop. Okay, that's not what we want. Because first of all, we want which pin? We want, that's, we can turn that off. We want pin 23. You can do PWM on pin 23, correct? I think GPIO can handle PWM. Whatever, we'll see. PWM. And then just run it? Link wiring pi. Okay. Enable this when using dev try sudo. Fine, I'll try sudo. Well, that's not promising, is it? Multiple points of failure, because right now we do not actually know if it is the program that's the problem or if it's the PWM. And how shall we test it? Well, we shall, or if it's the wiring. It could be a lot of things. We shall test it by unplugging it. Don't mind that, that was just a false input. Unplugging it and then bringing out the diode, I suppose. Diodes always help. Okay, let's run the program again. And nothing is happening. Now, once again, multiple points of failure. Is it the program / wiring, or is it the diode that's bad? Because it could be either. Ah, fucking hell. How am I gonna test the diode real quick? I do believe I can test the diode by just doing this. Yeah, I feel like that might be actually the diode. Because that should have lit up. Don't worry, I have a whole box of diodes. Let's pick a blue one, because blue ones are just the best. All right, blue and yellow. There we have it. Oh, this is already running. Well, that's not good. It's not good at all. Ah, it's absolutely always something, isn't it? It's absolutely always something. Hi there, Remco. Hi and welcome. How you doing? I heard you have fun. I heard you had fun. Huh? Didn't you? So this is basically bullshit. No worries, all we need to do is just fucking figure it out. MKT2C, do we have anything in here? No, we don't. CDSPI? Fuck.c, that's the name of the program. Okay. But that's not what we're looking for. What we need is something that's a bit more... Alright, so far, let's try just doing... Reading physics in Slovakia. I'm having the time of my life. Good for you. Okay, let's try this. Okay, couple of problems there. First of all, I did not in fact connect the pin. So, that could be reason number one why it didn't work. I was trying for a bit there. Problem number two could be that the program is just too quick. Did you reread the Pauli principle by any chance? Not yet, no, I got sidetracked a lot. An awful lot. Come on. Alright, that's milliseconds, I imagine. So let's do 3 seconds. Still absolutely nothing. You hear that? Wait, hold on. Me tapping on the wire. Wait, can you hear this? Like right now. I can bring the mic. I can bring it closer, I suppose. But when I put my finger to the wire, this is really wacky. It's really wacky because I'm not connected to anything else on the circuit, am I? Just the act of me touching the wire. That is really wacky. Why isn't wiring pi working? Why wouldn't you be working? GPIO 23. Well, that is your name, isn't it? Wiring pi pin 4? That is a pin 4? I'm sorry, that is pin 4? How much didn't help? That didn't help at all. Oh, why are you like this? Just do right 4, yes. I missed something. Oh, pin mode, right, yeah. Multiple points of failure. As I always say, multiple points of failure for output, yes. Compile again, run it. Oh, motherfucker. Okay, good, splendid, we've done it. We did the thing. Now if I plug it in, well then we're gonna have problems because it's clearly consistent, you know, it's on. It's on all the time. Turn off digital writes. low, unless there is some kind of proper way to turn it off. Okay, whatever. There we go, turn it off. Splendid, which means now what we need to do is we need to turn these off, turn this on, and turn all of these off, on. And then apparently we need to do pin 4, because it isn't pin 23 as I imagined, only it is pin 4. Why? I haven't got a clue. But now we can turn on GCC again to compile it, run it, and... Right, we need to run it with sudo for some reason. Why do I need to run it with sudo? I don't understand. I feel like that's a pretty clear... I feel like running it with sudo is a pretty clear example that I'm doing something wrong. Pretty clear sign. Why would I need to run it with sudo? I'm able to do this when using dev gpio mem. It isn't doing anything. Fake news. Fake news is what it is. Absolutely fake news. No, that's not the right tab. This is the right tab. Right, should be. No, wait, is it the right tab? No, this is the right tab. There we go. So this is pin 4. Yeah. And then I use the PWM example. That's it, that's all I get. This. I'll be honest, it isn't really working for me. Oh, it's because it's writing on the 1. Is that the issue? Right. Yeah, okay. Let's try it. Anyone remembers the definition of insanity? Just... I kind of forgot what the definition of insanity, you know? Oh damn it, I dropped the pin. I mean, not the pin on the LED. Something is happening in my brain today, I cannot think. Oh, where did I drop the LED? Can't find it anywhere. Well, that's why we got spares. That's why we got spares indeed. All I need to do is for this LED to light up. That is it. That's it. And thank goodness, hi Drali, hi, welcome, how you doing? And thank goodness I did think ahead to actually do the whole multiple points of failure thing, because otherwise I would have had a hellish time. Do you not set up a frequency anywhere? Do you just really wing it like that? PWM. Oh wait, I'm looking for examples, I'm looking for this. PWM. Soft PWM. What is the difference between soft PWM and PWM? Once upon a time, I let pins on GPIO expanders be soft PWM, but it's really not a good thing. What is soft PWM? Okay, we don't want soft PWM, we want PWM. Wiring pi I to C, wiring pi SPI, serial shift. That's it, there's no other PWM anywhere. These are the only PWMs. You are joshing me. Wiring pi. Do I really need to go into the biggest file? Oh, man, I get so excited trying to pull me because I love seeing how your streams progress. I remember when you weren't a VTuber or didn't have a good segues behind the scenes. I'm a proud fan and friend. Oh, thank you, Ali. I appreciate that a lot. It did change a lot since the first ones, didn't it? Because back then it was just like a stream of a number. That's it. Right now I have a whole camera set up like this. I can just switch back. It does feel a lot more professional. It's been a long journey. It really fucking was. Come on. Give me what I'm looking for. This is absolutely massive file. It's fine, I can find it. Okay, examples. Where are the examples one? Examples, yes, PWM. Okay. I was there for the 100 review, nostalgic man. You were there back when I was having fucking no viewership whatsoever. I remember. You were the first one, well, one of the first either, or the first person who actually watched the live streams. Back then it was just people who accidentally stumbled upon them. To this day, I cannot believe that I spent around 200 days streaming every single day with basically no one watching. I used to get excited when there were 2 people watching, because that means there was at least someone. I don't know, like, no one talking in chat was a standard, but I was at least excited when someone was watching. Right now, if no one is talking in chat, I feel weird. Lucky. PWM output. Okay. Very proud, yeah, thank you. Because, like, Happy came way later. Happy was also a proper legend when I was watching the streams, but Happy came after the addition to quantum mechanics video. Okay, why would this not work? This not work. PWM output, yeah. Let's print write SND, and let's have it be the writes. And now let's write. No, why did you just crash? The reason? Okay, there we go, we're back. So it is not doing anything. The LED is still dim. Hi, the shelter. Hi, welcome. Why is the LED still dim? What could be going wrong? That is the question. PWM write, or should be writing. Can I just, instead of the loop, instead of the massive big old loop, can I just do PWM write 4 and then something like 500? Can I just do this and see how it goes? Oh yeah, and then we're gonna need to delay it for like 3 seconds. It's still dim. What is happening? From where is trying to play the sound through the mask? Well, yeah, I mean, all of this. Okay, so like, eventually, you know, all of this will be inside of the mask, but for now, we're just trying to set it up ourselves. It's always something. You and your gay chemicals. Well, I do remember my gay chemicals. I would never forget my gay chemicals. Signal blue is the chrome. No, that's correct. So if I set it up as just output, was it output or just pin output? Pin output. No, just output. If I set it up as just output, and then instead of pin WM, sorry, if we do digital right, and then 4 and high, if we do this with the same exact setup, okay, nothing changing, then it works. It's not good. It's not great. That's in fact not great. Let's see how the PNW functions out of the wiring pi. There it is. So wiring pi takes in the pin, takes in the value. Yeah, big fucking shocker there. We have this track wiring pi nodes. We go in. GPIO to PMW port pin. Okay. That's curious. Channel value. That makes sense, but so you get the node and then you do PMW write node pin value. Okay. So what is the problem with my setup? This is pin 23, but wiring pi apparently uses it as pin 4 for some reason. Pin 5. Pin 1. Pin 16. What is up with wiring pi? Do I need to add in 23 in there? Is that wouldn't make much sense. I mean, I can try doing 23. Because I don't fucking see my notes. 23. No, still absolutely nothing. Oh, I just got so dizzy in my head for some reason. Oh. Really dizzy. That's probably due to my rage. Why aren't you working? Just do the thing that you're meant to be doing. I'm not gonna software implement PWM because I'm not an idiot. Why can't you just work? The beautiful fumes inhaled catching up to you. That might be it. I did start the stream on the beginning, like, well, not on the beginning, but a little bit ago. I did solder this, and I might have inhaled a bit. Okay. Wiring pipe PWM. Oh, I don't want software PWM. Oh, that's what soft PWM stands for. Oh. Right, that makes sense. Okay. That does make sense. So soft, not so soft like software, not soft as in oh, okay. Yeah, that makes almost sense. Soft PWM. But that feels silly. That feels very, very silly. Unless Zero doesn't have the capacity. That would be idiotic if it didn't have capacity to PWM, wouldn't it? Why wouldn't it have capacity? Examples again. Soft PWM. No, that goes for multiple things. Yeah, I have no clue. Why can't you just work like you're supposed to? What's code modulation? What? Oh, there are specific ones for I2S. That's useful to know, but not quite what I'm looking for. Why is this one by ring pi 0, by the way? And which one is 1? This one is a 1, 18. So if we just plug the yellow one from in between the two, if we plug it out and we just pop it into neck on the other side of the ground, like this. Okay, splendid. And then if we just... I am so dizzy! And then if we just do the same thing with a 1... What the fuck? I am sorry. So only certain pins can handle PWM. Because then what we can do is we can just uncomment all of this. Apparently only certain pins can handle PWM because I understand. Hi there, Rick. What are you doing, mate? I am making... PWM, ladies and gentlemen, PWM. Sick. Now, the reason why it was important that we do it with PWM is because we can unplug it now. We can take it, we can plug it into ground to the ground. I said we can plug in ground to the ground and then like this. And if we do the same thing, that's an uncomfortably gross sound. Okay, instead of going from 0 to this, let's go from 200 to 700. How about that? Also, let's remove this delay because that's unnecessary. Too disgusting. Let's maybe int delay is equal to, I don't know, let's do a 20 for now. And let's change the delay to something like a 20. Nope. Okay, so 400 to 600, apparently. I genuinely thought it was different, but... why does it sound so digitally? And also, the frequencies don't make sense. When I was testing the buzzers, the frequencies were completely different. Okay, listen, that's enough being possessed by a demon. Alright, okay. Okay, speakers, everyone! We did this fucking sound. The only problem is the frequencies don't match up, do they? Because we go... Oh, it's a constant frequency! It's a constant oh, because we're not changing up the frequencies, are we? Oh, that's useless! Okay, wiring pi, PWM change frequency. That's what we need. We need a constant value. We need different frequencies. Found that as a when it comes to frequency, very duty cycle. Bizarre, right? There's a broken from a balance PWM. Okay, is that wiring pi? I'm gonna guess it's wiring pi because 2 to 4095. Now for specific frequency, you can use the following relationship. Frequency in hertz is that's very wacky. I'm going to trust. Wait. The PWM clock. Okay. Wait, why are you doing it this way? Why didn't you do it backwards? That's not extremely focused as a plate, by the way. That is very accurate. And for some reason, it didn't cross my mind the fact that we don't actually want to be changing the loudness. We want to be changing the frequency. Why does it sound so digitally? Well, no, because normally if we were doing frequency, it wouldn't sound so digitally. It would sound quite fluid. Which means we want... right. As with Pac-Man, by the way, is my man running this on Arch? Set clock. Yes! Right? Wait, set range. Hold on, what is range? Oh, I couldn't help but notice these are kilohertz and megahertz. Different music notes in hertz. Because I feel like kilohertz might be... Yeah, a bit high if our lowest option is 2 kilohertz. That is problematic, quite indeed. Let's say, hypothetically, that we would like... Oh, there's PMW set clock, as mentioned at the beginning, okay. Change the PWM clock. Originally my code, but change from also there's not manual testing the scope. Okay. So right here we take a divisor. What are we doing now? I'm trying to play a music note. It's not going well. We take the PWM control. Okay. Right. So this is not exactly what we're looking for, is it? What we are looking for is set range. I want to see what that is. Okay, set the PWM range register. We set both range registers to the same value. You want different on your content? Write your own. Well, I know you can see because it's quite small text. That is, I like the sass. I like the sass. Undefined step. Okay, but how? What? Let's say hypothetically. Wait, am I supposed to implement myself? I can implement it myself, I suppose. Can't I? Yeah, let's try to do it manually. Maybe we don't. Let's set make it, and everything went well, as we all know. That's how it works. 1 output. Let's try to implement it manually. What kind of node are we going for? Let's do a simple GBD, which would be 98 Hertz, 123.5. Okay, is someone noting it down? No one is. I swear, everything I need to do myself. Unbelievable. 98, 123.5, and 146.8. Those are our hertz values. Now that is an inverse of a second, which means how many times something has to happen per second. Which means we just do 1000 divided by them of a delay, if I am not mistaken. And I might be mistaken, so take it with a grain of salt. So what we do is we do delay... No, for I in range, that's as Python make it. For int I is equal to 0, I is smaller than... Would there be some kind of clever way to... Well, we could just divide it and see what we get, correct? Because 1000 divided by hertz will give us the delay we want to use. And the delay, and 1000 divided by the delay we want to use will give us the... Right? Wait, am I thinking about this correctly? So like, you know, 1 second divided by x hertz will give us... Because hertz is, you know, 1 per second. So in this case, the unit is seconds. That gives us the delay of some kind of a seconds. Which means if we want to get back the 1, I know how idiotic it is since it is literally number 1, but hear me out. What we do is we multiply both sides by this and divide by this, which means 1 divided by a. Yes. Yeah, so we know the x, we know the 1. We need to get the a. Oh, and this tells us how many times we want to do it. That feels a bit too simple. I must have fucked something up. I definitely did, whatever. We'll have int nodes 3 is equal to... And what were the nodes? 98, 123 and 146. I'm certain that decimal points don't matter. And then for int I is smaller than 3, I plus plus. And then we'll have for int n is equal to 0. No, wait, yeah. N is smaller than nodes I n plus plus. And then what we do is we do... what do we do? Well, what we do is we enclose it all. Because we will need more than one line, I imagine. And then... Let me have a think. We write it as high. Yeah, which means that digital write 1 high and then low. And then in between them we will delay for 1000 divided by nodes I divided by 2. Correct? Okay. And is that correct? Well, we can just plug it in and see. I am fucking incredible! Oh, I am, like... Suck on that! Oh, now we can do even float, we can specify it even further, 0.5. and 0.8. Will you round it? You will. Oh, I can now do, we can do music with this now. Isn't this, I'm sorry, I don't mean to, you know, get ahead of myself or something, but aren't I incredible? What we're effectively doing is we're taking this Raspberry Pi and we're sending, this is good stuff. Now the only thing left for us would be to implement it better, probably. Can we delay it by... Yeah, we should implement it in some kind of better way. I'm pretty certain that the standardized system would be 1000 divided by nodes divided by 2. Except we don't want to repeat it. Yeah, so we should probably now go on to... Can you play some kind of simple version of the Maker theme? Well, actually, I could. Yeah, if I just do this sort of thing. Void play notes. That takes in float hertz like this. Then... if we take this, there we go, then this function right here should play heads, that would be our thing. Play it, and then this will give us a second. Add how long to play the note for. I know, Olo. I know, trust me. Trust me, I know. Do we do divide by time? Wait, if we increase, so multiply by time, I think this will do it. And I'm pretty certain we should be able to do just time, because comparing integers with floating points shouldn't be a problem, I think. And now if we do play notes, let's try it. I am thrilled to find out how they will go wrong. Notes I, and then let's do float times. Let's do it for 1 second, then a really short, then 2 seconds. I am really thrilled to find out how it will go wrong. Oh yeah, okay, that's actually a pretty simple way. I am amazing! Okay. Oh, how do you play City of Stars? Oh my goodness. Or make it theme. Yeah, let's do make it theme. So that is GG. We'll have to do it without chords because I don't know how to implement chords. Haven't got, yeah. I imagine there will be some kind of combination of the heads, but doesn't matter. And because, let's do make it theme. FL Studio, just to line it up better. La La Land posting. I was gonna do City of Stars, that's my, you know. Ali, have you seen La La Land? Okay, bro. People don't watch the same movies as I do. You know how few people even know what La La Land is? It's upsetting. That's why we fail as a society. I should though. I know I haven't. Yeah. Okay, we need to do single notes. Good enough. Lalan's the movie you've made it in it. Yeah, I played the main lead. Yeah, I'm Sebastian. I am literally Sebastian. Was it this? Without the chords, it sounds a bit. Oh, you can't hear it, but whatever. You'll see. More of a review for you, I suppose. Then. Okay, now what we need is an octave. So it will be okay. Okay. Minimize a bit. So it will be, instead of, we'll have first this, then we'll do delay for 1 second, and then we will have 1 second, I said, and then we will have play note, lower G, which is 98 for, let's say, wait, did I do that in seconds? I do believe I did that in seconds, which means 0.2. Then delay 0.2. Okay, that's how professionals write music. And then G, so 196. And then delay of 0.6. Right, and then let's try it. No, where did I miss one? Right here, okay. Oh, I just realized it should be 200 and 600, not 0.6 and 0.2. Uh-oh. That would have been quite quick. Yeah, and right here also should be 200 each. Wait, no, right here it should be 0.2, yes. It's going to be so cursed. It's going to be so absolutely cursed. Okay. You'll see, I know about all this, but I prefer listen to music. Whatever, photons have frequency, close enough. Seeing, hearing, same thing. So then we'll have another G, then F sharp. That's lower F sharp, which is 92.5. I can do floats there, right? Yeah, I can. Okay, good. Let's just remove all of this. Oh no, it didn't go any lower. Why is it the same noise right here? That doesn't go any lower than that. Is it because the difference is too small? Is it because it's rounding up too quickly? That might be it. I don't know if this will help. Yeah, it's just guess I'll just have to deal with it. Because then the next one will be E, which is 82.4. That's terrible. That is absolutely terrible. Okay. I guess it's because it's lacking precision too much. Is there a better way to delay? Raspberry Pi C, wait for microseconds. That would be nice. Sleep for microsecond slash nanosecond. Nanosecond to be even better. Oh, perfect. Oh, that's Pico. No, I mean 0. Raspberry Pi 0. pi 0. Nope. Beautiful. Okay, so this should give us more precision, which means it should give us better sound. You sleep. Which means what we do is we just change it to you sleep, and instead of 1,000 we do 1 to 3. And this should hopefully sound better. There, you see, I know what I'm doing apparently. Would you believe that? Would you believe it? I actually know what I'm doing. So then we have this E, then top E. E, then the E higher octave, that's 164.8. And then 600, and then we do it like this. There we go. Then the D and C, correct? I think so, which means 73.4. 73.4 and 165.4. 73.4 and 65.4. But then that's right here, 84.4. That is so silly. Okay, great. That is so wacky. Because then we do the exact same thing. The only difference is that this should be the top C, which means 130.8. And the difference in this case would be 600 right here, then 65.4 right here and here, and then D and E back, which means this back except swapped, and then and top E again, so 82. Hundreds, and then D, which is 73.4, and then top D, which is 146.8. Let's try it. Now what we can do is we can also do float speed is equal to a 2, and then we can go in actually and we can divide every single one of those by speed. And what dividing by speed will do is it will just increase the speed. Actually, we don't need to. What we can do is we can actually set up speeds to the macro at the very beginning, because then we don't need to do it every single time. Only right here we can do speed 2 and then time divided by speed. The delay, unfortunately, we'll need to divide by speed every single time. What should be just less things to add. I could just change all occurrences of delay, I guess. That would work. That would be probably quicker. Oh well, I'm committed now. I'm doing it this way because it's not all that difficult, to be honest. And so there we go. Now we do just C, then this is awesome. Hold on. I have an idea. If instead of defining speed right here, if we do a global int, or actually float speed, like this, is equal to 2. Actually is equal to 1. There we go. Then we can do for I in range. No, that's Python again, make it. Come on, get it together. Int I is equal to 0, I is smaller than, I don't know, 100, let's say, and then I plus plus. And on the beginning of every, well, on the end of every single function, speed plus equals 0.1. Oh, because speed has to be all caps, right? Speed. Rad jump. I mean, I don't know about you, but I think it's going really well. Oh, there isn't any delay between the final ones. Hold on, no, that needs to be fixed. This is ridiculous. We can start with the speed of something like 1.5 as well, so it wouldn't go too slowly. And then on the very beginning, we need a delay of like this. You can't see it right now, but I am actually jamming. I am curious how quickly it will get, because I did set it up to loop 100 times. So by the end, it should be like 90 times the speed, right? 99. No wait, 101. Yeah, 101 times the speed, sorry. I went the wrong way. Subtracting should have added. This is what is playing in my head every single waking hour, right? And it does speed up. I'm imagining an 8-bit make it right now. These speakers have got to be one of the best purchases I've made. That's because they were like $1 each. Speakers are really cheap. Someone could probably make a sick EDM song out of this. Isn't Cape already on it? It's really getting even more gooey. Welcome to my head, everyone. This is why I'm mental. Eventually it will probably reach a point where the amount of times it's repeating a loop isn't large enough for it to actually play a sound. That is, the loop basically iterator will get back to 0. And I feel like we're really reaching that moment right now. It started out really with really nice vibes, but at this point it's entering the, you know, jigsaw trapping you in the room and you're about to get your leg snapped in half. It's quite creepy. Okay. Let's just, instead of looping it, I would just like to hear what it sounds like. Well, let's loop it like 5 times. I would just like to hear what Make It theme sounds like on 100 times the speed. Oh, what about 20? Can you do 20? What about, I don't know, 5? 5 feels like a sweet spot. Like, it sounded really nice, and then my anxiety sped up by 100 times, and then I continuously reviewing all my decisions. I feel like speed of 2 really hits it. That is probably how I'm gonna end. This is probably the jam I'm going to end the video with, you know? I could set it up in a bit more of a clever way, I suppose. We need to think about how to implement it with multiple notes. Let's think about that. Because if you think about it, what we're effectively trying to achieve is a wave, right? Now, crucially, here's the thing. What we're effectively trying to achieve is a wave, however, with samples. So this is your sound in real life, right? Then, if this is your sound in real life, in our case, this is not what it looks like. In our case, what it looks like is this. This is what our sound looks like. Or even then, that wouldn't exactly be it. It would be more like... the other way. There we go. That's more of what our sound looks like. When you have multiple notes, that would be kind of like sine 3x plus sine 4x. Like this would be what multiple notes sound like. So in our case, it would look something like this. And I would need to figure out, well, yeah. This feels like something that would need PWM. Just for the heights. Because right here we're not dealing with a high and a low, we're dealing with multiple levels. Which means PWM would probably be necessary, unless we do software PWM ourselves. Yeah, so implementing multiple notes would be a bit tricky. Yeah, we might leave it there for now. We might leave the sound thing there for now. It's a pretty good spot, isn't it? I'd say so. It really feels like there should be some more to it, but I don't know how to combine them. I don't know how to combine notes. Because we cannot regulate voltage on a digital write pins. We can only do ones or zeros. I could do motor drivers, but that feels insane. There we go. There, I'm turning it off. I've turned it off. That was surprisingly productive. Well, I mean, we didn't achieve the thing I actually wanted to achieve, did we? What's more... Okay, to be fair, we are a spit away from implementing sound. That's because with the micro sleep, we can actually create all the different kinds of waves we'd like. So what we need to do is we just need to, for each sample, we need to make a function that outputs a wave, so kind of like our own version of a PWM, so software PWM. And then we'd need another function that takes in a sample and it plays that wave for the length of a sample. I know I'm not explaining it very well, but that's probably because, not probably, only that's because we'll do it next stream. And this stream I'm just explaining the rough idea. Anyhow, I think that might be it. I have this to do. I still have the video to make with the make-its and basketball hoops and such. Productive day while not achieving the goal. Classic make it. Yeah. Yeah. Well, unfortunately I do have a video to make. If Jesse was here, may their soul rest in peace, then what I would do, actually, is I would take the mask. Here's what I would actually do if Jesse was here. I would take the mask. I would take the speakers. I would probably pop them on right here, possibly at the top. And then once they're in place, I would also add in the... in my head thinking of it as a sound card. It's not a sound card. It's an audio amplifier. I would also pop in an audio amplifier at the top, and then I would actually solder everything together, finalize it, and then we could actually have proper sound in the mask, and then it would feel way easier to work on the software side. But yeah, oh well. We did play some music though. So I suppose that'll be it. Unfortunately, I'm sorry, but Papa needs to go to work. I do apologize, but Papa needs to go to work. So I suppose, for now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.